All right. Hello again. My name is Paul Myers, and welcome to Beta Things. Today we're going to be talking about one of my favorite topics, that's kinetic art. And so that's any kind of art that moves, usually in a cyclical fashion. We're going to talk about my favorite kinetic artists and what I've done to steal or adapt their work. For about 10 years now, I've been following various kinetic artists, and the first one that I saw was Mr. Ruben Margolin. Beautiful work that he does. He tries to mimic natural waveforms with his mechanisms. And this is a beautiful representation of that. Very complex, involving lots of gears and pulleys. The end result being these gorgeous, natural-looking waves. And he was sort of my introduction to kinetic art in general. Some of my other favorite kinetic artists include, this is Theo Jansen, who creates these things he calls strand beasts. They're beach walking mechanisms that are ostensibly autonomous. Some of them can sense if they're getting close to water, they can sense if the wind is getting too high, and they can batten themselves down for a storm. Just gorgeous pieces of moving art. But most specifically today, we're going to be talking about Anthony Howe and his work. You might recognize this sculpture from the Rio Olympic Games recently. It was meant to embellish the Olympic flame. But Anthony Howe's work has been in this vein for a long time now. He's been working on these sculptures that are, for the most part, toroids, donut shapes, with arms that constantly envelop on themselves, usually through wind power. And so I really wanted to make something like these, and I wanted to have them on my desk. I wanted something that I could 3D print and own and have this movement for myself and to share with others. And so I sort of dove deep down the rabbit hole of Anthony Howe's existing work to sort of try to figure out how he was going about what he was doing. And the biggest hurdle, the hardest thing to do, was figuring out how to translate movement between the arms along the ring. And so on this ring here, you can see there's something like 12 or 16 arms that are all turning in unison. And the way they do that is with these pins and forks. And so the pin fits between the prongs of the fork and translates its rotation onto the next arm. And actually I found that there was a chronology to this. There's actually a progression that he made in his work. And so you look at this one, this is an older sculpture, I believe, where the pins and prongs and forks are straight. And the problem with a pin and arm that is straight is if the forks are exactly the right distance apart for one pin to fit in, they'll mesh perfectly at the innermost and outermost extremes of their rotation cycle, but at 90 degrees, they approach each other on an angle, which means that in order for it to work at all, he had to bring the prongs of the fork apart, which induces a backlash in the whole system. It creates a little of extra play in order for it to work. So that was his sort of starting off point for that rotational translation. And then he moved on as he sort of figured out what was going on, I believe, and he created the prongs of a fork that were curved, so that at those 90-degree intervals, the pin could be constantly making contact with the prongs, and then at the inside and outside, it would still be making constant contact to remove that backlash. And then from there, he moved on to what I'm seeing here, which I believe is his most recent methodology for translating rotation, which was these curved pins and forks. which in theory should allow for constant contact throughout the entire rotation cycle. Now, I don't know what defines the curve that those pins and forks take on, possibly an involute, or possibly the curve doesn't matter at all as long as they're both the same. I'm not sure. Definitely a question I would like to ask you, Mr. Howe, if you feel like contacting me or maybe inviting me out to your beautiful sculpture garden in Washington. But yeah, so that was what I sort of found through my rabbit holing over Anthony Howe's work. What I really wanted to do was obviously create a smaller 3D printable version, which means that those pins would be 3D printed and they would be very small and very fragile and probably would break. So that was kind of off the table. The other option for that, to keep the sort of pin drive system that he has, would be to use little small pieces of coat hanger as the pins and forks, but that would require a lot of work, especially if I wanted to do the curve, which would basically be impossible for most people to put together. So what I did was replace that drive mechanism with angled gears on each individual arm. And so let's look at what I came up with. So obviously, not being wind powered, like a lot of Anthony Howe's work, this is powered by a crank. But you can see how each individual arm is toothed into the one beside it. It's they're all connected and in sync with involute gears. And it's a great little thing to have on your desktop and watch and play around with as you go. And it's a lot of fun. So let's see what's next. What do I want to talk about? This is about just over 60 pieces total. Lots of pieces in this model, including the arms, which are assembled in 2 halves, so that makes up the 60 pieces. And it gets to be quite complex. Let's look at the model here. Of course, I just dropped it, broke it. That sucks. Anywho, yeah, so my design process, I started with doing these arms with the gears, which are all threaded onto a piece of coat hanger, you can see there, and driven from both sides by gears. And those gears go down to another set that get brought down to a single point reduction, down to this gear, out to the side on an angled gear, which uses the overall rotation of the circle to impart rotation on the individual arms, and then is driven by a crank on another angled gear there. Just like that. So like I was saying, it's a very difficult model to put together, and requires a lot of finicky work, some sanding, a little bit of cutting pieces, and I want to release it to the general public through Thingiverse, but not yet. It's not ready yet. The pieces still need a little bit of changing, so what I'm looking for is what I'm going to call collaborators or contributors. If you have experience 3D printing, and you have a 3D printer and you're interested in having one of these, please contact me either in the comments below or through other means, and let me know your experience and what you're working with, and let me know. And if I think that we can work together, I'll contact you and I can provide you with the files, and furthermore I can talk you through, we can have video calls and conferences and talk about how it's put together, the hard parts of it and everything like that, and get you to the point where it's all together, and that's going to help me modify the file and get it ready for everyone else to print. So we're looking for collaborators, contributors. The other thing that I'm announcing today is that I'm also accepting students. So if you're interested in learning how to model mechanical things, or your inventions and stuff like that using Onshape, I'm taking on students. I'll be teaching through screen capture software so that I can share my screen, you can share your screen, we can work together on a project if you've got an idea, and get you to the point where you can be inventing things using 3D printing. So that's pretty much my spiel for today. Thanks for watching Beta Things. Let's keep looking to the future of mechanical technology together.